Question number 22, we've got a quadratic equation which needs to be solved. We're asked to give our solutions to three significant figures. This is a big clue, and the fact that it says that means that it's unlikely to factorise nice and simply, therefore we're going to have to use a quadratic formula or completing the square. Quadratic formula is that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is the number in front of the x squared term, b is the number in front of the x term, and c is the constant on the end. So if we take those values for a, b and c and plug them into that formula, minus 9 plus or minus the square root of 9 squared minus 4 times 2 times minus 7 all over 2 times 2. And then we type that into our calculator. Minus 9 plus the square root of 9 squared minus 4 times 2 times minus 7 all over 2 times 2. So one of the solutions found by adding the numerator is to three significant figures. There's our first, second and third significant figure, so we're rounding to the nearest 3 decimal places. One solution is 0.676. That was found by adding the numerator, the two parts in the numerator. If we go back into our calculation and change the add for a takeaway, the second solution is first significant figure, second, third. This time we're rounding to the nearest second decimal place. The 6 means the 7 goes up to 8, so it's minus 5.18. Part B. Solve this equation. It kind of looks a bit like a quadratic equation which we've had in part A, because we've got y squared terms and we've got y term, and we've got a number on the end, but the problem is the terms are on the denominator. There are several ways of solving this. I think the easiest way is to multiply through the whole equation by y squared. So we get 2 y squared over y squared plus 9 y squared over 9 over y minus 7 times y squared, and then on the right hand side 0 times by y squared is just 0. And the reason we do that is because that y squared cancels with that. The y squared divided by y just leaves you with y, so that's a 9y minus 7y squared equals 0. And then I'm going to take everything over to the other side, just tidy it up so the y squared term is positive. What we have now is a quadratic of exactly the same type as we solved in part A. So it's just a case of substituting these numbers. A is equal to 7, B is equal to minus 9, and C is equal to minus 2 into this formula again, and doing exactly the same steps. Be careful with the first part of the formula, minus B, because B is negative 9. You have take away negative 9, which is plus 9. If you're careful, type it into your calculator, though you don't need to worry about that too much. Anyway, you can do the rest of it. The solutions that you get to three significant figures are 1.48 and negative 0.193.